Hi friends, very good morning. Welcome to Anu Academy. Very good morning friends. So let us start today's class. Today's class, our subject is Theory of Machines. Theory of Machines, as we know, it is we'll be studying as kinematics of machines and dynamics of machines. So theory of machines, today's class, uh, we are uh, we have selected kinematics of machines. In that kinematics of machines, today's topic is friction, belt, rope, and chain drives and two-thread wheels. Okay, so friction, belt, rope, and chain drives, two-thread wheels. Okay, so let us start today's class. So I think all of you are preparing well for your exam. Okay, now we will start today's class. Okay, right. In a, I'll start from here. Okay, we'll start with the friction. The angle of inclination of the plane at which the body begins to move down the plane is called angle of friction. Okay, so always each and every topic we have to start with the definition, basics, and we have to go in depth. Then only we can understand, we can we can remind it properly. In a screw jack, the effort required to lift the load W is given by P equal to W tan into alpha plus phi, where alpha is helix angle and phi is angle of friction. The efficiency of a screw jack is given by tan alpha by tan into alpha minus phi. The radius of a friction circle for a shaft of radius r rotating inside a bearing is r sine phi. The efficiency of a screw jack is maximum when alpha is equal to 45 degrees minus 5 by 2. Okay, the maximum efficiency of a screw jack is 1 minus sine phi by 1 plus sine phi. Okay, so see here itself, sometimes we may get questions which are little bit confused. So see, efficiency of a screw jack is maximum when alpha is equal to 45 degrees minus 5 by 2, but here the maximum efficiency of a screw jack is 1 minus sine phi by 1 plus sine phi. Like that we have to remember the subject. Okay, then only we can select the correct option within the fraction of seconds. Right. Next, the frictional torque transmitted in a flat pivot bearing considering uniform pressure is 2 by 3 into mu into W into R, where mu is coefficient of friction, W is load over the bearing, and R is radius of the bearing surface. The frictional torque transmitted in a conical pivot bearing considering uniform wear is 1 by 2 into mu into W into R cosecant alpha, where R is radius of the shaft and alpha is semi-angle of the cone. The frictional torque transmitted by a disc or plate clutch is same as that of flat collar bearing. The frictional torque transmitted by a cone clutch is same as that of trapezoidal pivot bearing. The velocity ratio of two pulleys connected by an open belt or cross belt is inversely proportional to their diameters. Two pulleys of diameters d1 and d2 at distance x apart are connected by means of an open belt drive. The length of the belt is pi by 2 into d1 plus d2 plus 2x plus d1 minus d2 whole square by 4x. Okay, now we will continue. Right. In a cone pulley, if the sum of radii of the pulleys on the driving and driven shafts is constant, then cross belt drive is recommended. Due to slip of the belt, the velocity ratio of the belt drive decreases. When two pulleys of different diameters are connected by means of an open belt drive, then the angle of contact taken into consideration should be of the smaller pulley. The power transmitted by a belt is maximum when the maximum tension in the belt T is equal to 3 Tc, where Tc is centrifugal tension. Tc is centrifugal tension. Like that, we have to remember. The velocity of the belt for maximum power is root T by 3m, where m is mass of the belt in kg per meter length. The centrifugal tensions in belts have no effect on the power transmitted. When a belt is stationary, it is subjected to some tension known as initial tension. The value of this tension is equal to the average tension of the tight side and slack side of the belt. The relation between the pitch of the chain P and pitch circle diameter of the sprocket D is given by P equal to D sine into 180 degrees by T, where T is number of teeth on the sprocket. The two parallel and coplanar shafts are connected by gears having teeth parallel to the axis of the shaft. This arrangement is called spur gearing. Okay, so if we are talking about the gears, we have to know what are the exact definition of a gear and exact definition of a classified type of gear. So spur gear, this is the relation of this spur gear. Okay, next we'll discuss about this spiral gears. The types of gears used to connect two non-parallel, non-intersecting shafts are spiral gears. Okay, now two connected, two non-parallel, two intersecting shafts are called spiral gears. An imaginary circle which by pure rolling action gives the same motion as the actual gear is called pitch gear. It's called pitch circle. The size of a gear is usually specified by pitch circle diameter. The radial distance of a tooth from the pitch circle to the bottom of the tooth is called dedendum. Okay, so these type of questions sometimes we may get direct options, sometimes we may get link based options, sometimes we may get match the following type questions. Okay, so it's always better you whatever the topics you are reading, right, it's always make a habit of writing small notes in your own style, so that at the time of examination, at the time of revision, so that the notes will be helpful for you. Okay, so that's all friends for today's class. I think today's class regarding this friction, regarding this belt, rope and chain drives and tooth gears will be really helpful for your examination. It will be helpful for your assistant engineering examination conducted by Andhra Pradesh Public Service Commission. Okay friends, so if you have not subscribed our channel, please subscribe our channel. Please like and share our channel. We need your support. Please discuss with your friends regarding the class for going on in our channel. Thank you very much. Thank you for watching.